The first skill we did on this chapter was plotting lines using a table of values, and what we're trying to do now is go the other way, that when we've been given a line, we're trying to work out what was the equation which generated that line. Well, the first thing that we need to be able to understand is the general connection between the equation of the line and its picture. And here we've got what's called y equals mx plus c. So y and x are the two numbers that we've got on our axes. The m is the gradient. The c is our what we call y-intercept. That's the point where the line crosses the y-axis. So let's look at graph 1 and see if we can work out what its equation is. So if I look at graph 1, the y-intercept, where does it cross the y-axis? I'm just going to put some labels on here because I didn't label it all the way through. 1, 2, 3, 4, 1, 2, 3, 4. Okay. So here, my y-intercept, where does it cross the y-axis? It crosses the y-axis at 1. So the y-intercept was 1. Well, what's the gradient? Looking for the gradient, I'm going to look for the next point after here where it's on a grid line. And I can see up there, it's on my grid line. And I can draw my step in to work out what that gradient is. Remember, the gradient is how much you've gone up, which was 2, over how much you went across. So the y-intercept was 1. The gradient, which we call m, is the amount up, 2, over 1, which is just 2. So now I can just write it into my equation. Once I've found the y-intercept and the gradient, I just write it in. Y equals m. Well, m was 2, so 2x plus the y-intercept, which was 1. Y equals 2x plus 1. And that was the equation which must have given me line 1. Let's see if we can do the same with line 2. So, first thing I'm thinking, what is the y-intercept? Where does it cross this y-axis? Well, it crosses it at minus 1. So, the y-int is minus 1. The gradient, so I've got this point here. I'm going to look at the next point which is on a grid line, which is here. I've gone 2 across and 1 down. So, it's going to be a negative gradient. It's negative 1 over 2, negative a half. So my equation, y equals the gradient times x, negative a half, x, plus minus 1. If we're being really clever here, we're going to get rid of those two signs. We can replace the plus minus just with a minus. So it's negative a half x, take away 1. Okay, copy that down, make sure you understand what we've done there, and then when you're ready, we're going to go on to some questions for you to do yourself. Okay, the first set of questions should be nice, relatively easy numbers. Gets a bit more difficult on the second one. For each of them, find the y-intercept, find the gradient, and then just plug that straight into y equals mx plus c to give the equation of the line. Good luck. Okay, so we've got our 6 equations here. Y equals a half x plus 2, y equals minus 2x plus 3, y equals a half x, y equals minus a half x plus 1 and a half, y equals minus 3x minus 1, and y equals 2/3 of x minus 3. Couple of things to note here. When the y-intercept is negative, as it is with 2 and 3 down here, we should see that it crosses the y-axis below the origin. So that's what the minus 1 and the minus 3 tell us. It crosses below the origin. The gradient tells us whether it's upward sloping or downward sloping. So, for example, 1 and 3 up here both have positive gradients, so they're upward sloping. The other thing to notice about 1 and 3 is they are parallel lines. They go side by side like train tracks. They're never going to meet. And we could spot that straight away from the equation because the gradient of the first one is a half. The gradient of the third one is also a half. If the gradients are the same, then you know that the lines must be parallel. Okay, very well done.